now we are going to practice using their formula for derivatives to calculate derivatives. Now, I stated earlier that if f of x is equal to x squared, then the derivative is 2x. Let's show that. Let's find it. If f of x is equal to x squared, then please find f prime of x. Well, we know by definition that f prime of x is equal to the limit as delta x goes to 0. Now, some textbooks and teachers, instead of saying delta x, they use the letter h. H is in Harry. So, you can write h goes to 0 of f of x plus h. Anytime I write delta x, you write h minus f of x over h. Okay, now, to calculate the derivative, it's basically all algebra, except you keep writing down the word limit, which is calculus. Now, what you want to do is eventually factor out delta x from the top, and then kill off delta x over delta x. And then substitute 0 for delta x. You want to factor out delta x from the top, and then cancel it out with the delta x factor in the bottom, and then plug in 0 for delta x. And when you plug in 0 for delta x, then you don't write limit anymore. All right. What's the job of f? What does it do to what's in the brackets? Answer is it squares it. Whatever goes in the brackets, you square it. So to find the numerator, it's this, take away that. Well, f of this, I know what f of that is. I take that, and I square it. Minus. Now you can say you know what f of x was. They told you. F of x is x squared. Or you can say, I'm going to take what's in the bracket, x, I'm going to square it. This gets divided by delta x. 100% algebra, other than writing the word limit. Same with the next line. X plus delta x squared. You need to know how to square a sum. We're adding two things, you need to know how to square it. You square the first piece plus 2 times the product of these two things, x, delta x, plus the second one squared, delta x squared. Just don't write it that way. If you square in delta x, put it in brackets. Minus, says minus, minus x squared over delta x. Well, I know one thing. X squared and x squared, if I'm subtracting them, and I am, I get 0. Now, the nice thing is that everything that survived in the numerator, every term that survived in the numerator has a delta x. So now we can factor out delta x, and then I'm going to cancel it with the one in the bottom. So the bottom is delta x, and that's a delta, trust me. And then in the top, we're going to factor out the delta x. And when we factor out delta x from the top, we'll have 2x plus delta x. Why? Because delta x times 2x is the same as 2x times delta x, which is exactly the first term. And delta x times delta x is delta x squared. So it is correct. And now we cross off delta x over delta x. So we have the limit as delta x goes to 0 of 2x plus delta x. That's all that survived. And now replace 0 for delta x. So you have 2x plus 0. You want to write the plus 0, fine. You then do their addition. It's 2x. The derivative, the f prime of x, the derivative of f, is 2x. Just like I said it would be. Okay, so I want to do one derivative of each different type of problem. But I do want to do another polynomial. 2x squared minus 3x plus 5. Okay, I want you to find the derivative. So we know f prime of x is equal to the limit as delta x goes to 0 of f of x plus delta x minus f of x all over delta x. And if you guys write h instead of delta x, fine, write h instead of delta x. This is equal to the limit as delta x goes to 0 of f of this. Instead of x, I write x plus delta x. I'm going to copy here. Instead of x, I write x plus delta x. 2 times x, this is how I write x, 2x squared minus 3 times my x, which is x plus delta x, plus 5. Now, since f of, minus f of x, minus f of x. But f of x is 2x squared minus 3x plus 5. And all of this gets divided by delta x. So far, other than writing the word limit, all algebra. Let me come a little bit to the left in case I need this space. Okay, how much is x plus delta x squared? And then whatever it is, I double it. It's x squared plus 2 times the two things being added plus the second thing squared minus this. Since I didn't distribute the 2 yet, let me not distribute the 3. You want to do it this step? Fine. This minus f of x, 2x squared minus 3x plus 5. And all of this is over delta x. This is equal to the limit as delta x goes to 0, 2x squared plus 4x delta x plus, because it says plus 2 times delta x squared minus 3x minus 3 delta x plus 5. Okay. Now, like I was starting to say, if f of x is a polynomial, then everything in here is in the first bracket, and we're supposed to subtract it. That is, I am now supposed to take away 2x squared. Okay, I just did. I'm supposed to take away negative 3x. Here it is, negative 3x, I took it away. I'm supposed to, from here, I'm supposed to take away 5, plus 5. There's plus 5, I just took it away. And please don't forget to divide by delta x. That's a very nice way of doing the subtraction. Okay. Now, amazingly, we do have a silly error. So let me do this in a way. 2 times x squared is 2x squared plus 2 times 2x delta x is 4x delta x, and then it's plus. Somehow I didn't put the plus sign in. And then it's 2 times delta x squared, which I did put. Okay, but it wasn't in red, it was in black, sorry. So now it turns out, and it's always going to turn out this way, and if it doesn't, you made a mistake. It's going to turn out that every term that survives has a delta x. It always will. And then, when you factor out delta x from the top, it's going to kill off the delta x in the bottom. And from here, when you pull out delta x, you have 4x left over. From this one, when you pull out delta x, you'll have 2 times delta x. And from here, when you pull out delta x, you have minus 3. So what we have is the limit as delta x goes to 0 of 4x plus 2x delta x minus 3. And so now, up to now, other than writing down the word limit, it's been 100% algebra. Now, we do a little calculus. And notice how simple the calculus is going to be. I'm going to replace 0 for delta x. So I get 4x plus 2 times 0, which is 0, minus 3. That is, I get 4x minus 3. I'm not saying this is an easy problem. I'm saying the calculus was easy. The calculus just said, oh, take delta x and call it 0. That's all the calculus said to do. The calculus did say to use the formula. Okay, just call delta x 0, or let delta x be 0. That's all the calculus was in this problem. But it's not an easy problem, I admit that. The calculus, piece of cake. Let us now do a problem that involves square roots. Okay, what I want to remind you is a couple of things. Remember that the square root is, say, 7 times the square root of 7. On one hand, it's also known as square root of 7 squared. On the other hand is 7. The square root of a number times the square root of the same number is 7. For example, if somebody asks you, what does that mean? The square root of 17 is that special number. What's the property that square root of 17 has? Oh, that's the number that when you multiply it by itself, you get back 17. The reason the square root of 25 is 5, that's because when you multiply this number, that is that number, they're equal. That is, when you multiply this by itself, you get back 25. But this number is 5. When I multiply it by itself, I get back 25. The square root of 17 is a special number. What's special about it? Oh, if I multiply it by itself, which I just did, I get back 17. I didn't use any math there to get 17. I used the definition. The square root of 6 is that special number. For example, if I told you square root of 6 was 2.73, and I'm right. I'm not right, but make believe I'm right. Then we know one thing. If the square root of 6 equals 2.73, then 2.73 times 2.73 is equal to 6. But you know what? That's the square root of 6. I said it. The square root of 6 is 2.73 times, now that's the square root of 6. And that's 6. That is the square root of 6 times the square root of 6 is 6. Which is also known as the square root of 6 squared. Square root of 17 times square root of 17 is the square root of 17 squared. That is, if you have a square root of a number and you square it, you get back that number. Now, let's look at conjugates. If you have a plus b and you multiply it by a minus b, you end up with a squared minus b squared. And why are this and this conjugates? Because all that changed is the sign. That is, if you had x minus y and you multiplied it by its conjugate, x plus y. Keep in mind that when you multiply it, you can switch to order. That is, this mess is the same as x plus y times x minus y. Just like 3 times 7 is 7 times 3. This is equal to x squared minus y squared. Same for the top. When you multiply conjugates, you square each of the terms. If somebody asks you, what is 7 minus 2 times 7 plus 2? You can say, oh, they're conjugates. It's 7 squared minus 2 squared. It's 45. I mean, of course, you can say this is 5 and this is 9, and 5 times 9 is 45. But here's another way of doing it. If somebody asks you what 3x plus 4y times its conjugate, if that's plus, you write minus. This here is like the A on the top, plus, and 4y is like the B. Well, like I said, that's A. I defined A to be 3x, and 4y to be B. This is like A plus B times A minus B. So we're supposed to get A squared minus B squared. That is, we get 9x squared minus 16y squared. But more important, notice that the things are being squared. And if you have a square root number, at the far left, if a square root number and you square it, no more square root. If you have a square root number and then you square it, no more square root. So now we have a way of getting rid of square roots. Let us look at an example, and then we will use this in calculating derivatives that involve square roots. Suppose you have the square root of x minus, say, the square root of y. And you multiply it by its conjugate, square root of x plus square root of y. Well, this whole thing is A, and if we call that whole thing B, well then that's A minus B. But that's the same as A, and that's the same as the B on the other side. So it's A plus B. Ah, I know what that is by now. I know what that is. That's A squared minus B squared. A is square root of x. It's A squared minus B squared. That is, it's x minus y. Notice, the final answer has no more square roots. If you have the square root of x minus z, and you multiply it by its conjugate, just change the sign in the middle. I like to call this the first and that the second, or A and B. That's A plus, that's B. So I'm supposed to get A squared minus B squared. Well, A squared is x and B squared is z squared. But most importantly, I started off with square root signs, and my answers don't have square root signs. Multiplying a square root by the conjugate gets rid of the square root sign. Okay, having said that, let's do a derivative. Let's calculate a derivative using a definition that has square roots. The function has square roots. If f of x is equal to the square root of x minus 3, find the derivative. Okay, well, use the definition. Equals to the limit as delta x goes to 0 of f of x plus delta x minus f of x all over delta x. This is equal to the limit as delta x goes to 0. Again, it's this piece minus that piece. Well, what is this piece? No matter what you put in the brackets, take away 3 and then put that strange looking symbol on top. Okay, I take what's in the brackets, I take away 3, and I put square root on top. Minus f of x. F of x is x minus 3. And all of this is over delta x. Now, there's no way right now, at least, to factor out the delta x from the top. So we want to change the way the top looks. And when you want to change the way something looks, that means you want to multiply by 1. You can always multiply by 1. Now, we like to get rid of the square roots. We have the square root of one thing minus the square root of another thing. Multiply by the conjugates. The square root of the first thing plus the square root of the second thing. But if this fraction is to equal 1, you have to do the same to the bottom. Okay. So this is equal to the limit as delta x goes to 0. Now the bottom. We're not going to distribute the delta x. It's delta x times this mess. The square root of x plus delta x minus 3 plus the square root of x minus 3. Okay, now let's see what the top is. Since it's conjugates, we should know how to do it. If I call this whole thing A, well then this whole thing is A. They're the same. If I call this B, well then this is B. A plus B. This here is A minus B. Well, I know where A plus B times A minus B is. It's A squared minus B squared. Well, if this is A and I square it, I get what's underneath the square root sign. Minus B squared. Well, if this is B and I square it, I get what's underneath the square root sign. I have to take away everything underneath the square root sign. That is, don't write for the numerator minus x minus 3. Yeah, you're taking away the x. But you're supposed to take away all of this. You're supposed to take away the minus 3. I mean, if you want to write minus x plus 3 instead, that's okay. But that's skipping a step. Let's not skip a step. All right. Now, what is the numerator? What is the numerator? Well, first, let me write down our favorite word in it. Well, we're subtracting. This has x and this bracket has x. Exactly x, not x minus x. They both have x, and we're supposed to subtract. Well, that's 0. They both have minus 3. When you subtract, you get 0. You know, a lot of students will say, oh, yeah, x minus x is 0. But then when I tell you what x is, if I tell you x is minus 7, you go and you change this to negative 7 plus positive 7. Nonsense. If these two numbers are the same and you subtract them, 0, as quickly as that. You need to understand that if x minus x is 0, then regardless of what you plug in for x, you're going to get 0. Okay, so why did I say that? I guess I said that for the negative 3's. If both of these numbers are negative 3 and you're subtracting them, you get 0. All that survived is the plus positive x. That is, the numerator is just, I meant to say plus delta x. The numerator is just delta x. And the bottom is delta x times this square root now. X plus delta x minus 3 plus the square root of x minus 3. Well, delta x over delta x cancels out to 1. And now, just let delta x be 0. Then you have 1 on the top, and in the bottom you have the square root of x minus 3. You don't have to bother adding 0. Plus another square root of x minus 3. If you add the same thing to itself twice, I don't care what it is. you get 2 times it. So the final answer is 1 over 2 times the square root of x minus 3. And I just want to confirm that this is right. I use what's called the shortcut method, and it's absolutely right. Okay, so it's 1 over 2 times the square root of x minus 3. Now, the next type of problem I'm going to do involves a fraction. We did polynomials. We did just now a square root. Next, we're going to do a fraction. Suppose I tell you that f of x is equal to 1 over, well, let's make it 4. 4 over, x minus 3. 4 over x minus 3. And I ask you to find the derivative. Okay? So, f prime of x is equal to the limit as delta x goes to 0, f of x plus delta x minus f of x, all divided by delta x. And this is equal to the limit as delta x goes to 0. Now, what does f do to what's inside the bracket? Well, first thing it does is it puts 4 on the top. And then, whatever's in the bracket, it takes away 3. And that goes in the bottom. So what's in the brackets goes in the bottom, and then you denote you're taking away 3. Minus this. If you forgot what f of x was, you put 4 on the top, and in the bottom, you write that minus 3. And all of this is over delta x. Okay, now we want to write the numerator and denominator without denominators. For example, what's above this line is the numerator. 2/3, for example. It has a denominator. What's in the denominator is below this line. 7 plus 3 over x minus 4. It has a denominator. We don't want these. Somehow we want to get rid of the equivalent of the 3 and the x minus 4. We don't want denominators in the numerator. Everything above this line is the numerator. Everything below it is the denominator. In the numerator, we have denominators. We don't like that. We do not like denominators in numerators or denominators. For the record, underneath that red line that is in the denominator, there's no denominator. It's just delta x. Okay, so that's code for we don't like the way this looks. We want to change the way it looks. We want to multiply by 1. If we multiply by x plus delta x minus 3 times x minus 3, top and bottom. The reason we're allowed to do that is we are multiplying by 1. Why do we want to do this? Well, let's distribute. This times this. Look at it on the side. 4 over x plus delta x minus 3 times x plus delta x minus 3 times x minus 3. This cancels out, and you're left with 4 times x minus 3. When you multiply this by that, well, you get 4 over x minus 3 times x plus delta x minus 3 times x minus 3. This cancels out. We rigged it. And then you get 4 times x plus delta x minus 3. Okay, let us write this stuff up. So, this is equal to the limit as delta x goes to 0. This times what's in front, we just did that. We got 4 times x minus 3 minus, and this times that was 4 times x plus delta x minus 3. Okay, so that's what the numerator is going to be. Let me get rid of our side work. If you had more space than I did, you would literally do side work on the side. Don't do side work right in the middle of the problem. Now, the denominator is simply delta x times this times that. It's delta x times x plus delta x minus 3 times x minus 3. Now, probably the simplest way to clean this up is instead of distributing the 4, we can factor out the 4. It's 4 times x minus 3. That gives us this minus, and it's 4 times x plus delta x minus 3. That gives us this. And the bottom doesn't change. So rather than distributing, we just pulled out. Rather than distributing the 4, we pulled it out instead. Okay, this is equal to the limit as delta x goes to 0 of 4 times what's in the brackets. Well, subtraction, I see x and I see x. I subtract and they're gone. I see negative 3 and I see negative 3. I subtract and there is 3. But please don't say, oh, negative, excuse me, don't say delta x survived. Negative delta x survived. Negative delta x over delta x times x plus delta x minus 3, which I'll put in right now, minus 3 times x minus 3. Well, negative delta x over delta x is negative 1. So we have the limit as delta x goes to 0 of negative 1 on the top, excuse me, negative 4 on the top, because 4 times negative 1 is negative 4. And on the bottom, you have x plus delta x minus 3 times x minus 3. And now I'm going to substitute 0 in for delta x. And the top is negative 4, and the bottom is going to be x minus 3, because I don't have to add the 0. It's going to be x minus 3 times x minus 3, which is better known as x minus 3 squared. And let me make sure that this is right. Yep, that's right. Okay, so there's the answer. 4 divided by x minus 3 squared. Now, since we've just been using the definition, let's just review what this means. What does it mean that the derivative is negative 4 over x minus 3 cubed? We just learned that the derivative is negative 4 over x minus 3 squared. Okay, remember, the derivative is the slope formula. Derivative gives you the slope. So what is going on? Just in case this graph happens to look like this, just in case the graph just so happens to look like this, and it does, trust me, I now have the slope formula. For example, f prime of 4. Just plug in 4 for x. It's negative 4 over 4 minus 3 squared. But 4 minus 3 is 1, and when I square it, it's still 1. And negative 4 over 1 is negative 4. That is where x is 4, namely right here. The slope of that tangent line is negative 4. The derivative tells tangent lines. If you want to know the slope of the tangent line at 0, just plug in 0 for x. Get negative 4 over 0 minus 3 squared, which is negative 4 over negative 3 squared, which is negative 4 over 9. Right here, where x is 0, the slope of this line is negative 4/9. The derivative is a slope formula. Sometimes I like to call f prime of x L of x. You plug in an x, you get slope. M is slope. Okay, so we use the definition using the regular derivative formula. Now let's use the definition for the alternate derivative formula. So now the alternate derivative formula gives you the definition precisely at a point. Okay, for example, if you are told that f of x is equal to x squared, the instructions would be, if f of x equals x squared, then find f prime of 3 using the alternate derivative formula. Alternate derivative formula. ADF. Okay, find f prime of 3. Now, so we use the alternate derivative formula. We know that f prime of c is equal to, by definition, the limit as x goes to c of f of x minus f for c over x minus c. But I'm telling you what c is. F prime of 3, well, I'm replacing x. Excuse me, c with 3. Is the limit as x goes to 3 of f of x minus f of 3 over this is not working. Okay, excuse me, it should work. Over x minus 3. So this is equal to the limit as x goes to 3. Well, f of x, that was given, it's x squared, minus f of 3, well, 3 squared is 9, over x minus 3. Now this doesn't have delta x's or h, so we're not trying to kill off delta x over delta x. But this is a limit that I think we might have actually done earlier in the limit section. Since when you, okay, so first you should plug in 3, and you get 9 minus 9 over 3 minus 3, which is 0 over 0. That means you have to factor. So I'm back to writing limits. Notice that when I substituted in 3, I substituted 3 in for x. I did not write limit. But now I'm back to limits. If I factor the top, which is x squared, or can be realized as x being squared minus 3 being squared. 3 squared is 9. It's easy to factor the difference to squared. You have to have a minus in the middle. Write down the things that were being squared 2 times. X and 3 were being squared. One gets a plus, one gets a minus. Divide this by x minus 3. This is always 1. So then we have the limit as x goes to 3 of x plus 3. Replace x with 3. So we get 3 plus 3, or 6. That's using the alternate formula. Okay, that's what you use to use it. That was an example of using the alternate formula. Now, the thing about the alternate formula is, if somebody said to you the following, if somebody said to definition you want. They say if f of x is equal to x squared, then find f prime of, I think we just did 3. Now, there are two ways of doing this. You can say f prime of x is equal to the limit as delta x goes to 0 of f of x plus delta x minus f of x all over delta x, and keep going, and eventually you'll get 2x. That is, f prime of x is equal to 2x. F prime of x is equal to 2x. But we want f prime of 3. That is, x is 3. So you get 2 times 3 or 6. That's one way of doing it. Or, you could have we just did it. You can use the alternate rule. F prime of 3 is f of x minus f of 3 over x minus 3. Excuse me. The limit is x goes to 3. And you will also get 6. Now, this formula has one drawback. This formula has one drawback. Let's look at it very, very carefully. If I ask you to do the following, I'd say, okay, if f of x is equal to x squared, find f prime of 3, f prime of 4, f prime of 5, and lastly, f prime of 6. I ask you to find a derivative at those 6 values, those 4 values, 3, 4, 5, and 6. Now, one way of doing it is to say f prime of x is equal to the limit as delta x goes to 0 of f of x plus delta x minus f of x over delta x. And do all the necessary work and get 2x. Okay? And then you say, all right, f prime of 3 is equal to 2 times 3, 6. F prime of 4 is 2 times x. That is 2 times 4 or 8. F prime of 5 is 2 times 5 or 10. F prime of 6 is 2 times 6 or 12. So I spent a lot of time calculating this formula. So I only had to do it one time. And then fairly easily I got the other derivatives. Okay, like I said, that's one way of doing this. The other way of doing it is to use the alternate derivative formula. Let's actually do it once or twice. So now we have that f prime, well, let's do f prime of 4. F prime of 4, using the alternate rule, is the limit as x goes to that number of f of x minus f of that number, 4, over x minus that number. And this is equal to the limit as x goes to 4. Well, f of x is x squared, and f of 4 is 4 squared, or 16, over x minus 4. If you substitute in, you get 0 over 0. 4 squared is 16, minus 16 is 0. 4 minus 4 is 0. So now we're back to limit. X goes to 4. You factor the numerator. You get x plus 4 times x minus 4 over x minus 4. This cancels out. So you have this limit. You plug in 4 for x. 4 plus 4 is 8. Okay, so now we have f prime of 4. So now we have to do the whole thing again for 5. The limit as x goes to 5 of f of x minus f of 5 over x minus 5 divided by x minus 5. The x minus 5's cancel. You're left with the limit as x goes to 5 of x plus 5. So instead of x, you write 5 plus 5, or 10. But now you have to do this for f prime of 6. Then you have to go back and do it for f prime of 3. You don't want to do it. You don't want to find many. You want to find derivative given a function. I want to make sure we're talking about one function. If you want to find the derivative of one function at different values, like 3, 4, 5, 6, or 24, negative 18, 11, the square root of pi, don't use the alternate formula, because you have to do the limit process for each one. You got to do a limit process for x equals 4 and x equals 5. Okay, it's a lot easier to use the long, their delta x limit. Keep going, get 2x. Do it one time, and then f prime of 3 is 2 times 3. F prime of 4, 2 times 4. F prime of 5, 2 times 5. F prime of 6, 2 times 6. Now, if somebody asks you what f prime of x is, don't use the alternate formula, because the alternate formula gives you the derivative of f prime of a number. Okay, now the next thing I want to show you is how you might use these definitions of derivative to prove our fact. Let's think. Here's a nice fact that we should be able to prove. If our function is differentiable, that means the derivative exists. If our function is differentiable at a value, then it must be continuous. So we have this fact, or theorem. If f of x is differentiable at x equals c, then f of x is continuous at x equals c. Now, let's just talk for a moment how a derivative may not exist at c. For example, if f prime of x, actually I think we had an answer like negative 4 over x minus 3 squared. We actually did this using the long form. I think, and I might be wrong, I think f of x was 4 over x minus 3. We calculated the derivative, and this is what we got. Well, you know what? F prime is 3 is not going to exist. You have negative 4 over 3 minus 3 squared, which is negative 4 over 0 squared, which is negative 4 over 0, which is undefined. You can't divide by 0. The derivative doesn't exist at 3. And actually, if I'm not mistaken, I drew this graph for you. I said here is 3, and the graph looks like this. There's no tangent line at 3. I mean, there's no tangent line at 3. The curve isn't even continuous at 3. Okay, so let us prove our theorem. And I guess we're going to use the alternate derivative formula, and we'll prove it nicely. Now, let's just review something. Remember that the main, we did 1a, 1b, 2, and 3. 1a was the limit for continuity at c. We did the limit from the left of f of x. It exists. We did for b of f of x. Now, whenever the left limit equals the right limit, that means the limit exists. The limit exists. And it equals that common answer. Well, of f of x. If I give you this, it's kind of understood that since this limit equals something, excuse me, that's a typo. It should not have that plus sign. If the left-hand limit equals the right-hand limit, then and only then can we say that this limit has an answer. And it equals the common answer to those, say L. Okay? So if I make this statement, if I say that this limit equals something, then I'm saying the left limit equals the right limit. Okay, so I'm actually saying statement 2. If I just say this statement here, I'm saying statement 2. The left limit equals the right limit. If the left limit equals the right limit, then they must both exist. So this statement says 1 and 2. 1a, 1b, and 2. And statement 3 says that the limit as x goes to c of f of x must equal to f of c. That is, we said that f for c must equal L. Okay, that was how we defined c. The common limit must equal to f for c. But another name for that common limit is that. All right. Now, all I'm going to say is f for c equals L. That's mandatory. This must equal f for c. This is another way of saying a function is continuous. If you show that the limit as x goes to c of f of x is nothing more than f of c, it's continuous. But to prove that something is continuous, you really need to do this. You really need to show those 3 things. All right, enough. So, let me erase this nicely and then do our proof. It might be hard for some of you, but nonetheless it's an elementary proof. That is, it might be really, really hard, but other proofs are 20 times harder. Hence we call it an elementary proof. All right. Now, I want to show that this is f for c. I want to show that's f for c. So let me start off with it. The limit as x goes to c. Now I'm going to play games with this. I'm going to say f of x, just like it said. But I'm going to play games with it now. I am going to play games with it. I'm going to add 0. This is f of x minus f for c plus f for c. All I did was take away f of x and add it back, f for c, and add it back. Okay? In fact, associative law allowed me to do that. What's in here is still f of x. You have f of x and you take away f for c, and then you add back f for c, you have f of x. Now, I'm going to mess with what's in the brackets a little bit. I'm going to multiply by 1. I'm going to multiply by 1. I'm going to take f of x minus f of c. I'm going to divide it by x minus c. And then I'm going to multiply back by x minus c. Please don't forget to add f for c. Okay? this portion right here is just f of x minus f of c, because this kind of cancels. But we don't want it to cancel. We want to take the limit. We want to do the limit now. We want to do the limit. We have a sum. So we have the limit of the first term plus the limit of the second term. Okay, I'm running out of room, so I need to move to the right. So let's use all of the right. Now, okay. So now first I'm taking the limit of this product, but I can break up the product. I can take the limit of the first factor times the limit of the second. So this is equal to the limit as x goes to c of f of x minus f for c over x minus c times the limit as x goes to c of x minus c plus f for c plus the limit of f for c plus the limit of f for c as x goes to c. Now, this first limit, okay, let's look at the second limit. C minus c is 0. It is not true that anything times 0 is 0. This is calculus, and that's no longer true. Anything times 0 is not 0. Undefined times 0 is not 0. For example, 1 over 0 is undefined. 1 over 0 times 0 is not 0. It is not true that anything times 0 is 0. This limit might be undefined, but it isn't. You know why? We said this is the derivative formula. This is f prime at c. But I said f of x is differentiable at c. That is, this is a real number. It's not undefined. So the product is 0. So the product is 0. Plus, now, as x changes, remember, f of a number is a constant. If I ask you to find f for 7, I tell you f for x is 2x. If I ask you to find f for 7, it's a constant. The constant doesn't care about x changing. That is, or am I out of space? That is the limit, for example, as x goes to 5 of 3 is just 3. And if I have f for 3, that's a constant. I get back f for 3. It doesn't care that x is changing. It stays that constant. Okay, now. So, a couple of more lines and the proof will be complete. This limit is just f for c. But defined value times 0 is 0. Plus f for c is f for c. And basically, I wanted to show that this equals f for c. And I did. So, f of x is continuous at x equals c. And it's the end of the proof. Alright, good luck with this stuff.